Okay, students. Question number 20. So here we are given using the fact that sine a plus b sine sine a plus b equal to sine a cos b plus cos a sin b. This is our formula. This is our fact. You have to use this fact and differentiation. Obtain the sum formula for the cosine. You have to use this fact and also you have to use differentiation and differentiation. You have to use differentiation and question is obtain obtain the sum formula obtain the sum formula for cosine. Students, here we are given the sum formula of sine. Using the formula of this sine a plus b equal to sine a cos b plus cos a sin b and differentiation, you have to obtain the formula of cosine. Clear? So let's start with the given. We are given sine a plus b equal to sine a cos b plus cos a sin b. So here one point to be keep in the mind is that here a and b are the functions. They are the functions of some variables. So we'll assume that let a and b are functions are function of t. You can take variable t, x, y, anyone. So here we are assume that angle a and b are the function of t and they are vary. Done? In trigonometric ratios, these functions can be vary. So they are the function of suppose t. So now we have to use differentiation according to a question. So taking differentiation on both sides with respect to t. So taking differentiation on both sides with respect to t. So differentiation of this sine a plus b with respect to t is d by dt of sine a plus b equal to differentiation of this term plus this term. So it's a d by dt of sine a cos b plus d by dt of cos a sin b. Differentiation of two terms which are in addition. So students, differentiation of this sign is cos. So it's a cos a plus b. And again, differentiation of this a plus b is differentiation is with respect to t. So it's a dA by dt plus dB by dt equal to, again, differentiation of this sin a into cos b. These two ratios are in multiplication. So here you have to apply product rule. So differentiation is sin a as it is. Differentiation of cos b is minus sin b. Again, differentiation of this b is dB by dt plus this cos b as it is. Differentiation of sin a is cos a. Again, differentiation of this a is dA by dt. This is the differentiation of this sin a into cos b plus, again, you have to consider the differentiation of this cos a into sin b, and therefore cos a is as it is. Differentiation of sin b is cos b. Again, differentiation of b is dB by dt plus, now this sin b as it is. Differentiation of cos a is minus sine A. Again, differentiation of A with respect to t is dA by dt. So differentiation of this term is this one. Clear? So now we're writing simplification form. The simplified form is cos A plus B into dA by dt plus dB by dt equal to. Now students, here you can see that this sin A sin B and this sin A sin B is common. So taking this minus sin A sin B and minus sin A sin B common from this one, and this cos A cos B and cos A cos B in these two terms is also common. Right? So first we are writing this cos A cos B. So cos A cos B common term, and remaining terms are dA plus dB. dA by dt plus dB by dt. Minus sign is common, so it's a minus. Sin A cos B is also common, and remaining terms are dA plus dA by dt plus dB by dt. Clear? So here again, this dA by dt plus dB by dt is common, and it will be cut from the left hand side. So we'll get the our final answer cos A plus B equal to cos A cos B minus sin A sin B. This is the cosine formula for the sum. Sum formula for cosine that you have to derive. Is that clear? Now, next one is question number 22. We will do question number 21 later on. 19 and 21. First, we will do question number 22. That is of differentiation of any determinant. We have discussed determinant entire chapter, but here you have to discuss the differentiation of determinant. So it's a very easy. So here we are given y. One determinant say y, and the value of determinant is f of x, g of x, h of x, l, m, n, a, b, and c. This is given determinant. And your question is find or prove that. You have to prove that differentiation of this y, that means dy by dx, that means differentiation of this determinant is f dash x, f dash x, g dash x, h dash x, l, m, n, a, b, and c. This you have to prove. Right? So you have to obtain differentiation of determinant. For that we are given y. So let's start with the given. So here y equal to f of x, g of x, and h of x, and this l, m, n, and a, b, and c. Then these are the constant terms. Then l, m, n, a, b, c. These are the constant terms. You have to consider that one as a constant. So how can we differentiate this type of determinant? So first you have to write differentiate on both sides with respect to x. So we are getting dy by dx. So dy by dx is nothing but the differentiation of this determinant. Now students, for the differentiation of the determinant, first you have to differentiate first row and keep remaining two rows as it is. Then plus you have to differentiate second row and keep remaining both terms as it is, plus then you have to differentiate the third term and keep remaining two terms as it is. That is the differentiation of determinant. Similarly, you can perform the differentiation in column also. For column, first you have to consider the differentiation of first column, keep remaining two columns as it is, plus then you have to consider the differentiation of second column, keep remaining two columns as it is, plus differentiation of third column and keep remaining two columns as it is. That is how you can perform the differentiation of any determinant. So here we'll consider the differentiation according to its row. So what you have to do? First step, you have to consider the differentiation of only first row. Done? So what is the differentiation of first row? It's the f dash x, g dash x, and h dash x. Because they are the function of x, g is the function of x, h is the function of x. So differentiation of f of x is f dash x, differentiation of g of x is g dash x, differentiation of h of x is h dash x. So here you perform the differentiation of first row, and you have to keep remaining two rows as it is. L M N L M N and A B C. Done. Plus second term, you have to consider the differentiation of second row. Remaining two rows will be as it is. So first row is f of x, g of x, and h of x. Differentiation of L. It's a d by dx of L, d by dx of m, and d by dx of n. Done. This is the differentiation of second row. Differentiation of L with respect to x, differentiation of m with respect to x, differentiation of n with respect to x. Third row as it is, A, B, C. Plus third term. For the third term, you have to consider the differentiation of third row only. Keep row 1 and row 2 as it is. First row is f of x, g of x, h of x, L, M, N. And differentiation of third row is d by dx of A, d by dx of B, and d by dx of C. Done? So here our L, M, N are the constant terms. So first term will remain as it is. Differentiation of this constant with respect to x, differentiation of this m with respect to x, and differentiation of n with respect to x will be 0. So this row will be 0. So value of this entire determinant will be 0. Plus again a, b, c are the constants. So differentiation of that constant with respect to x are also 0. Therefore, for this third term, these three elements are also 0. So value of this determinant is also 0. So 0 plus this determinant. And that's why we'll get our answer dy by dx equal to this. These two terms are 0. So we'll get f dash x, g dash x, h dash x, l, m, n, a, b, c plus 0 plus 0. So that you have to prove. Clear? इसमें कोई doubt? Students? Very good. Y is equal to e raised to a cos inverse x. A cos inverse x. Condition is minus 1 less than or equal to x less than or equal to 1. So for this, you have to show that that means you have to prove 1 minus x square b square y by dx square minus x dy by dx minus a square y minus a square y equal to 0. This you have to prove. Done. So again, start with the given. We are given y. So now y equal to e raised to a cos inverse x. Done. For our proof, we require d square y by dx square, that means second order derivative, as well as dy by dx, first order derivative. So first we'll differentiate given y with respect to x. So taking differentiation. So differentiate on both sides. Differentiate on both sides with respect to x. Differentiation on both sides with respect to x. So we are getting this dy by dx. So our dy by dx is equal to, now, differentiation of this exponential function. So e raised to x will be e raised to x, and then you have to consider differentiation of x part. So it's e raised to a cos inverse x, and again you have to consider differentiation of this a into cos inverse x. So that is equal to, a is constant, and differentiation of cos inverse x is minus 1 upon square root of 1 minus x square. Done. So we can write our dy by dx as a minus minus a into minus a into e raised to a cos inverse x whole divided by square root of 1 minus x square. Right? Say given this y as a 1. So students, if we check equation number 1, we can write this e raised to a cos inverse x equal to y. So by using equation 1, we can write dy by dx as a minus a into this term e raised to a cos inverse x. E raised to cos inverse x is our given y. Done? So replace this value with y. It's a minus ay whole divided by square root of 1 minus x square. Done? So keep this result as a equation 2. This is our equation 2. That will be useful in our later simplification. This is our given y. Now, this is our dy by dx. Now again we have to differentiate this one with respect to y. So we'll get the second order derivative. So now differentiate on both sides with respect to x. This is our first order derivative. In our proof we require second order derivative. So again we are taking differentiation on both sides with respect to x. So for the left hand side we are getting d square y by dx square. So this will be d square y by dx square. Now students, you have to consider the differentiation of this one, minus a minus ay upon square root of 1 minus x square. So taking this minus a as a constant, and then we'll consider the differentiation by quotient rule. Then, so taking this minus a as a constant, and again we consider the differentiation of this term as a quotient, y upon square root of 1 minus x square. So that differentiation is denominator as it is, it's a square root of 1 minus x square, and differentiation of numerator, the differentiation of y is dy by dx minus